America's second-largest reservoir is collapsing in real time, and 40 million people depend on the water that's disappearing behind Glen Canyon Dam. Lake Powell has now fallen to just 22% capacity. What was once a massive reservoir stretching across the American Southwest is rapidly turning into exposed canyon walls, dead marinas, and miles of cracked earth. Behind the 710-foot concrete wall of Glen Canyon Dam, the water that powered cities' farms and entire states is vanishing faster than the system was ever designed to survive. And the most disturbing part is that federal engineers and water officials warned for decades that this exact collapse was mathematically inevitable. The white rings keep rising on the canyon walls. They mark where the water once stood and where it no longer reaches. Lake Powell sits at roughly 23% of capacity. The massive reservoirs behind Glen Canyon Dam, built to stabilize an entire region, has lost 3/4 of its designed volume. The dam itself, a 710-foot concrete structure, stands intact. It is the water that has disappeared. The white rings cut across the canyon walls like watermarks of failure. Every layer marks a level the reservoir no longer reaches. Glen Canyon Dam was finished in 1963. It rose from the canyon floor as tall as a 70-story building, one of the largest concrete structures in the United States at the time. 8 penstocks, each 15 feet across, feed water to turbines with a combined capacity of 1,320 megawatts. The reservoir behind it was meant to hold more than 24 million acre-feet at full pool. In wet years, it would capture surplus. In dry years, it would release what the river itself could not supply. That was the design. The dam did not create water. It held water across time, so the legal promises made in 1922 could still be met when nature fell short. In 1922, 7 states divided the Colorado River, as if the water would always be there. The agreement promised roughly 16.5 million acre-feet every year across states and Mexico. The problem came later. Scientists found the years used to build the deal were unusually wet. The river often delivers far less. The shortage was built into the system from the beginning. Reservoirs like Lake Powell simply delayed the consequences. The dam performed as engineered. It generated power. It stored water. It released controlled flows downstream to Lake Mead and the users below. Cities grew. Farms expanded. Suburbs spread across desert valleys that receive almost no rainfall on their own. The system appeared permanent because the buffer behind the dam absorbed the shortfall. That buffer was never infinite. It was simply large enough to delay the reckoning. In 2000, the pattern shifted. The basin entered what researchers now describe as aridification, not a temporary drought. Temperatures rose. Snowpack in the Rockies melted earlier and produced less runoff overall. The river's annual flow dropped further on top of an already insufficient baseline. By the 2020s, the imbalance had become measurable in real time. In recent years, the basin consumed around 13.3 million acre-feet, while the river delivered closer to 11.9 million. The difference came out of storage. Lake Powell and Lake Mead both declined. The white rings on the canyon walls lengthened and multiplied. Tiered shortage declarations began in 2021. Arizona, Nevada, and Mexico took the first required cuts. When levels kept falling, deeper reductions followed. Officials called the measures temporary. They were intended to buy time while longer solutions were developed. The lake continued to drop. Boat ramps ended on dry ground. Marinas operated at reduced capacity. Side canyons that once held water now showed exposed rock and sediment. The physical margin for error narrowed. Engineers proposed emergency fixes. Lower intake systems could keep turbines running if water levels dropped further. Other plans involved coordinated low-level releases from major reservoirs. None of them solved the central problem. The Colorado River was still delivering less water than the system demanded. That should have solved the problem. It didn't. The real problem sat elsewhere. It sat in the original allocation that exceeded the river's reliable long-term supply, and in a climate that has shifted drier in ways the 1922 framework never contemplated. The dam and its outlet works were built to manage a reservoir. They cannot manufacture the missing water. The system below still had legal capacity on paper. The physical water did not arrive in the quantities the compact assumed. The scale of the mismatch now reaches every layer. Individual farms in Arizona's Yuma area and California's Imperial Valley rely on steady deliveries through canals. When allocations shrink, they fallow fields or pump more groundwater, which raises costs and risks long-term aquifer damage. Cities such as Phoenix and Tucson receive Colorado River water through the Central Arizona Project Canal. Reduced deliveries force greater reliance on other sources or deeper cuts in use. Las Vegas draws primarily from Lake Mead, but sits inside the same interconnected system. Power from Glen Canyon helps stabilize the regional grid. When reservoir levels fall, generation drops even before full shutdown. The effects compound across states that were never meant to compete directly for the same limited supply. This is not the first time large engineered systems met a natural reality they had not fully priced in. In 2005, Hurricane Katrina struck New Orleans. The levee and floodwall system had been designed and maintained around historical storm data and cost-benefit calculations that treated certain high water events as sufficiently unlikely. Subsidence wetland loss and the possibility of stronger storms or different tracks had been discussed in reports. Action lagged. When a major hurricane arrived and the system was tested beyond its core assumptions, the physical failures cascaded. Here, the mismatch is slower and drier, but the pattern rhymes. A legal and physical architecture was built on a limited record of favorable conditions. Warnings accumulated over decades. Response remained incremental until the physical thresholds approached. If the current trajectory holds and new operating rules are not in place, two outcomes become more likely. Lake Powell could fall close enough to minimum power pool that generation drops sharply during peak summer demand. The grid would then rely more heavily on other sources, while temperatures in the desert cities sit above 110 degrees. Backup systems exist, but they were not sized for sustained shortfalls across multiple critical loads at once. Alternatively, if levels near the dead pool threshold around 3,370 feet without coordinated new protocols controlled releases through the dam become severely limited. Water would pass only when natural inflow exceeds surface losses. Downstream users would face more variable and less predictable supplies. The savings account function of the reservoir would effectively end. Both paths remain possible rather than certain. They depend on winter snowpack, the speed of conservation, and whatever rules replace the current guidelines. The data contain ranges. Tree ring reconstructions of long-term flow vary by 1 million acre-feet or more, depending on the exact sites and methods. Climate projections show further declines in runoff, but the exact percentage by 2050 carries uncertainty bands. A single strong snow year can slow the drop in reservoir levels and buy negotiating time. A string of poor years accelerates it. The post-2026 operating guidelines are under active federal review. States have not reached full consensus. The process includes environmental analysis and public input. Outcomes could include deeper required reductions, different triggers tied to combined reservoir storage, or federal imposition of rules if agreement stays out of reach. How those rules interact with existing water rights tribal claims and environmental needs is still being shaped. The physical behavior of the dam and river at very low levels also carries some engineering variables around sediment movement and outlet performance that operators continue to study. What happens to a city or a farming region when the legal share it was built around can no longer be delivered in full year after year? The question is no longer theoretical for the people already living with reduced deliveries. It is the daily arithmetic of allocation pumping costs and fallowed ground. The white rings on the canyon walls continue to form higher relative to the remaining water. Glen Canyon Dam holds its shape. The turbines and gates remain in place. The river that feeds the system does not. Negotiations over new rules continue while the physical margin narrows. 40 million people and the agricultural output that reaches far beyond the basin still depend on deliveries the original accounting never fully secured. The waterline does not pause for agreements. The clock on the next set of decisions runs on the same schedule as the dropping surface.